This is a short video on simplifying square roots. I'm going to go through the process on several examples, and then I will give you a chance to practice with some examples, and then I'll go through them and so you can see if your answers are correct or not. We're going to start with the example of the square root of 54. There are a couple of different ways of simplifying this. One method is to prime factor and look for repeats of a certain number. The other is to break it by the perfect squares. I'm going to do a combination of both of these methods so that you can see both methods. I'm going to start with complete the perfect squares method. The perfect squares, remember, are 4, 9, 16, 25, 36, and on in that same pattern. And you get a perfect square when you take a number times itself. So for example, 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is 16, so the square root of 16 is 4, and so forth. So what I want to do is find one of these numbers that divides evenly into 54. The perfect square that divides evenly into 54 is 9. So I'm going to go square root of 9, square root of 6. The square root of 9, as I said earlier, is 3, because 3 times 3 is 9, so I get 3. The square root of 6 does not divide evenly by any of these perfect squares, so it remains square root of 6. And you have taken the square root of 54. Square root of 48. Now, the best method is always to pick the largest perfect square that divides evenly into the number. And sometimes that doesn't work because we don't recognize that there's a larger perfect square in there. So I'm going to look at some perfect squares to begin with: 4, 9, 16, 25. And I want to see which one divides evenly in here. I know 4 goes in here 12 times, 9 doesn't go in, but 16 does go in 3 times. So I'm going to simplify this, or break this, to square root of 16, square root of 3. The square root of 16 is 4, and there is no perfect number in 3, so it remains the square root of 3. So 4 square root of 3 is the square root of 48. Now I'm also going to show you the prime factoring method, and many students like this method. So I'm going to do this again. And what they do is they break this using a factor tree. So they get square root of 2, square root of 24, or if you remember this from elementary school, factoring something. Putting a 2 in again, I get 12. Putting a 2 in again, I get 6. Square root of 2 again, I get square root of 3. Every time you repeat one of these sets of numbers, you get the square root taken off. So square root of 2 times square root of 2 is just 2. Here's another set, that's just 2. And so what I basically have is 2 times the square root of 3, which is 4 square roots of 3. This is just another approach to finding the square roots. Square root of 136. So I can look at my perfect squares again and see which one goes in there evenly. 4, 9, 16 are my numbers, 25, 36. And I want my number to divide evenly in here. I'm going to start with 4 because I know 4 goes into 36, so it's going to go into this whole number. And 4 is going to go in there, let's see, 3, that's 12, 34 times. And I can double check. 30 times 4 is 120, plus 16 is 136. Now if I look at that 34, the 34 is made from 2 times 17, so none of the perfect squares will go in there evenly. The square root of 4 is 2. Since nothing divides evenly that's perfect into the square root of 34, it remains square root of 34. Now I'm also going to do this method with prime factoring, so you can check that out. Maybe you like that method. The square root of 136 divides evenly by 2. 2 goes in there, let's see, 6 times 12, so 68 times. 68 divides evenly by 2, 34 times. 34 divides evenly by 2 17 times. So now I'm going to look for my repeats. There's a repeated 2, so I get square root of 2 times square root of 2 just gives me plain 2. No repeats here, so I'm going to have to put these back together. So I really have 2 square root of 2 square root of 17, which is 2 square roots of 34. So notice the same answer, two different methods. Okay, let's go to the square root of 200. What I would like you to do is to pause, press the pause button on the video, and see if you can do this one on your own, and then when you're finished, come back and I'll be doing it again. Alright, let's look at the square root of 200 now that you've tried it on your own. I'm going to do the perfect square method first, and so I'm thinking about my perfect squares are 4, 9, 16, 25, on down. The one that I recognize that's going to go in there is 100 because my number ends with 2 zeros. So I'm going to break this to square root of 100 times square root of 2. The square root of 100 is 10, so I have 10 square root of 2 as my final answer. Now if you chose the other method with prime factoring, it would look something like this. 2 goes in there 100 times. 100 breaks by 2 50 times. 50 breaks by square root of 2 25 times. So far square root of 2, square root of 2, square root of 2, square root of 25. And square root of 25 is 5 times square root of 5. Now I'm going to look at my repeats. Square root of 2 times square root of 2 is 2. No repeat again on the square root of 2, so square root of 5 is a repeat, that's a 5. And all that's left over is that square root of 2. So I have 2 times 5 times square root of 2, which is 10 square roots of 2 as my final answer. Okay, hopefully that's what you got when you did your problem. Now we're going to do another one. I have the square root of 225. Okay, I would like you to pause, see if you can come up with the answer for square root of 225. If you didn't recognize this as being a perfect square, it is 15 times 15, so your answer should be 15. But as I said, if you didn't recognize it, then let's see what we can do with this. I think that I would put in here square root of 25, and it goes in here 9 times. And the square root of 25 then is 5. And the square root of 9 is 3. And 5 times 3 is 15. Now if we look at the other method with prime factoring, the square root of 225, first factor I would probably put in is the square root of 5. And the square root of 5 is going to go in there, let's see, that's 4, it's 20, 45 times. The square root of 45, I would probably put in another square root of 5 and 9. And the square root of 9 is made from the square root of 3 times the square root of 3. My repeats are a 5, so square root of 5 times square root of 5 is 5. The square roots of 3 are repeats, so I end up with 5 times 3, which is 15. Okay, let's try another example. I have the square root of 550. Go ahead and press the pause button and do this one, and then when you're finished, hit the play button and see if we can agree on an answer. Okay, square root of 550. I'm going to go with the perfect square method first. Let's see if I can find a perfect square in here. Let's see. 25 should go in here because it ends with a 50. And the question is, how many times does 25 go into 550? So 550 divided by 25 is 22. Okay, the square root of 25 is 5. The square root of 22 is the square root of 2 and the square root of 11. Neither one of those is perfect, so it's going to remain square root of 22. Okay, let's do the prime factoring method. Square root of 550. Okay, the first number I'm going to put in there, let's see, I'm going to go with 10. Square root of 10 and the square root of 55. The square root of 10 is made from the square root of 2 and the square root of 5. And the square root of 55 is square root of 5 and square root of 11. I have a repeat at the square root of 5, so that's just giving me a plain 5. So I have square root of 5 times square root of 5 or 5, square root of 2, square root of 11. So I really have 5 square roots of 22, which is similar, or the same, I shouldn't say similar, it's exactly the same as above. Okay, another example, square root of 224. Go ahead and press pause and see if you can come up with an answer on this one, and then hit play again to see if we can compare and agree on an answer. Okay, our value is the square root of 224, so I'm going to use the perfect square method. The perfect square that goes in here is 16. Square root of 16 times square root of 14 is 224. So the square root of 16 is 4. Square root of 14 is made from 2 and 7. Neither of these is repeated or is it perfect, so my final answer is 4 square root of 14. Now using the prime factoring method, a nice prime factor in 224 is the square root of 2, and it goes 112 times. The square root of 112 goes 2 and 56 times, so square root of 2 square root of 56. That's square root of 2 and square root of 28. That's square root of 2 and square root of 14. And 14 is square root of 2 and square root of 7. Okay, let's look for repeats. I have a 2, I have another 2, and no repeat there, so go back to square root of 14. So my final answer is 4 square roots of 14, just as on the top method. Hopefully that's what you got when you did your problem. That concludes my short video on simplifying square roots. Remember, if you're having difficulties with this concept, please stop in and see me for extra help.